I want you to think of any and all odd numbers. Pick any two odd numbers. Doesn't even have to be on this list. Big, small, any two odd numbers. Now add them together and notice that your sum is an even number. Any two odd numbers will always equal an even number. Now I will show you why this is true. First, let's think of what an odd number is. And let's also think of what an even number is to help us examine our situation here. We'll start by just listing a few. So our odd numbers are listed 1, 3, 5, 7, 9, 11. And we have some evens. 0, 2, 4, 6, 8, 12. Well, how do you know that an even is an even and an odd is an odd? Remember when you were a kid, especially if you had a brother or a sister, remember how everything had to be fair. Anything your sibling had, you had to have one too. Kids are great for keeping track of equality. So if your mom bought, say, your sister a candy bar while they were at the grocery store, your mom knew that if she only had one, she'd never hear the end of it out of you. So she had to buy two, one for your sister and one for you. At a very early age, you understood your evens. If you ask an elementary school student, what is an even number? You are very likely to hear, an even number is where two people can share where none is left over. And I think we can agree that this is true. So, what's an odd number? I think the same student would say, an odd number is when two people share, but there is one left over. This is also true. We can take the child's response and think of evens as pairs. A pair is a value of 2. So I'm going to see how many pairs I get with a random even number. Let's pick the number 6. So here are 6 sticks. 1, 2, 3, 4, 5, 6. And let's pair them up. See, there is no stick left over. Now let's try an odd number. Let's do 7. 1, 2, 3, 4, 5, 6, 7. And let's try and pair up all of these sticks. Well, there's a pair. Here's a pair. Here's a pair. But oops, we have one left over. But what if we were to add 7 sticks to 7 sticks? So here's our first 7. And let's do another set of 7. And we'll pair these up as well. Now, I have one left over from the first set and one left over from the second set. Now I have another pair. Then 7 plus 7 sticks equals 14, and that's an even number. Now that we have a good visual understanding of how an odd plus an odd equals an even, it's because we can see that we can make pairs with no leftovers. The next thing I want to do is have this make sense algebraically. So first, we must define what is an even number. Remember how I said before that a pair is a value of 2? A pair of 1s equals 2. Here's a 1, and here's a 1, and that's a pair of 1s. That equals 2. A pair of 3 gives you 6. So here's 1 3, and here's another 3. That's one pair of 3s. And that gives you 6 sticks total. We can base our algebraic definition off of this concept of a pair. A pair is 2. A pair of 3 gives you a total of 6, which is the same as saying 2 sets of 3 equals 6. And that's the same as saying as 2 times 3 equals 6. Notice that when you're multiplying by 2, it's always going to be an even number. Therefore, we can say that an even number is 2n, and n can be any positive integer. Since an odd number means that you can have 1 left over after pairing, we can say that an odd number equals 2n plus 1, and the plus 1 is your leftover. You could also say that an odd number is 2n minus 1, because after you minus the 1, you'll have 1 left over. Now let's add up all of our odds. There's 3 ways we can do this. Our first way is to add our first odds. 2n plus 1 plus 2n plus 1. Odd plus an odd. 2n plus 2n gives you 4n. 1 plus 1 equals 2. 4n gives you 2 pairs. 2 gives you 1 pair. No leftovers. Let's try 2n minus 1 plus 2n minus 1. Here we get 4n minus 2. Same situation. 4 gives you 2 pairs, 2 gives you 1 pairs, and nothing left over. Last one, we can mix our numbers. 2n plus 1 plus 2n minus 1. Well, that just gives us 2n because the 1's cancel out. And there we just have, oops, that's supposed to be a 4. That gives you 2 pairs. So, an odd plus an odd will always equal an even.